Hello everyone. Today I'm going to be talking about home cockpit wiring, specifically cable management. I'm really excited for today's presentation because it helps you avoid all of those situations where you're ready to take off or ready to start your engine. You click, 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 almost start it, and then realize a wire fell off. You have to go under the cable, under your simulator, look at all the cables, find which one fell out, figure out exactly where it went to the board. So that's just a disaster all around. So today, let's start it off with cable management, and then we'll go next on to the wiring. So my first tip for your cable management is to plan, plan, and plan. So if you can get a really good draft of your simulator setup and then go from there, it'll make all the difference. Right here, I have a drawing, and I put my monitors right there, my yoke, throttle, and then I planned out that it would be the best location to put a USB hub just under the desk, mounted with some command strips, and if that won't do it, you can mount usually to the under your desk with some screws and brackets if you don't mind drilling into your precious desk. The same thing with the power supply. The computer goes to the power supply, which goes to the outlet, and then everything is just kind of routed nicely. My tip is to add 8 inches to your measured wiring, and then just buy the cable that length so that you don't have a bunch of extra wire, or even worse, in my opinion, is a wire that's too short and is just kind of awkwardly dangling, ready to get tripped over. My second tip is to fasten things wherever possible to your wall or your table. I really like these adhesive table clamps, or cable clamps right here. If you pop up them, you can swing wires in, and that makes it really nice for modular systems where you say, take out your yoke a bunch, and you just want to put it back in, switch out your hardware however you want to. So it's really, in my opinion, very important to keep this flexible, adaptable, because your simulators will likely change. My third tip is to use hook and loop, or Velcro tabs. I guess that is what I was thinking of as hook and loop before, but it's Velcro. Now, if you can get all of your cables into one central, kind of cable grouping, that can help you a lot with your wiring. You can see this image on the left, and then if you imagine all of the wires just expanded everywhere, it's very nice to just have this one central place right here. And if you're extra fancy, you can use this fancy cable mesh right here, wire it all up, shove everything through, use some zip ties. You can get a really clean situation there. You can also use automotive conduit, or just sections of zip ties, or hook and loop wraps. So that is my probably favorite tip, just to keep everything nice and tidy. Now, my fourth tip is to think long and hard about your power distribution. I'd always recommend using a surge protector connected to your computer, just because that is expensive stuff. Some of it is rated, some of it is less sensitive than others, but I like to just play it safe, put a surge protector on everything. If you put your power strip kind of central to your whole system, it looks a lot cleaner than if you put your power strip off to the side and then route really long cables all the way to that side. My fifth tip is to use 90 degrees. You can see on the right image, all of these 90-degree cables look really nice. It made my brain explode a little bit how clean it is, versus the one on the left, which also made my brain explode, but for completely different reasons. You can see these are all routed cleanly, nicely. They don't take the path of least resistance. There's some thought put into where they go, where they came from. As you can see, they definitely followed tip 1, to plan. Now, my sixth tip is to label the cable. You can use these bread tags, which is something I saw on Pinterest, which I thought was really cool, until I realized that it means that 1 week you have to eat 12 loaves of bread. You can also use electric tape. And if you have a label maker, you can use that, print out really nice labels. You never have to think about what that random cable goes to. I use this bread bag tip right here, and I labeled my air fryer with, "This is a wire." So naming it does come in handy. I wouldn't recommend this convention. On a little bit more detail on the electrical tape, I have this color standard that I like a lot. You use orange for computer hardware, you use yellow for primary controls, green for off-the-shelf components, and then blue for custom devices. And so this, you just like at a glance think, oh, this is that type of thing. And then I use white for everything else. You can just use a Sharpie. Super easy, just at a glance, what is this? And that is really important. My 7th tip is to think a lot about your USB hubs. I really like this sort of USB hub. A lot of ports, easily turn them on and off, and then really well built. So this Case's 16 or 10 port USB hub is my favorite. If you're using kind of the smaller USB hubs, make sure that you have enough power for your devices. If you're drawing more than half an amp, and you can usually see on electronics how much current they draw, and then just add that up. If they're going to draw more than half an amp, then, or even close to that total, make sure you're powering your USB hubs or your USB ports. Technically, you can have up to 127 devices hooked up to a computer through this crazy pyramid of USB hubs. So you don't have to worry too much about device numbers, although you will hit some practical limitations if your software can't really cope with that, or if your power is running out in that way. Let's now go on to a little bit of electrical engineering. That word's really scary, so let's instead call it just like wiring or voltage. That's a scary word too, though. So let's just start out with a super simple circuit right here. That's an alliteration, actually. We have our battery connected to a resistor, connected to a LED right here. The battery just powers it all. The resistor makes sure that the LED doesn't get burnt out through too much current, too much electricity going through it. And then the LED just sits there and looks pretty. It lights up. You can see this is just a circuit. The current goes from the positive terminal all the way around to the negative terminal. I like to think of these as cars, and I also like to have way too much time with PowerPoint animations. Oh, look at them go. I have this number, 220 ohm. That's the resistor rating. This is for 3 volts, but there's a different value for 5 volts. And we'll talk more about this math later, and how you can find your different resistors for your different LEDs and different voltages. So what we're doing right now is just showing that this Arduino, you can hook up as a power supply right here. The negative goes to ground, the negative side of the LED, which I'll talk a little bit about later. And then the positive end is going to 5 volts. We have that same circuit being complete, so you don't have to stress too much about the Arduino being different than a battery. And now if we turned it off by disconnecting it, the LED turns off, just like a circuit. And if you zoom in with a microscope, you can actually see the little cars falling into a canyon. Now we want to actually be able to control it instead of just hooking up wires. It's a little too simple, or a little too basic. So let's hook up, instead of the 5-volt pin, we'll hook it up to pin 2. And then we'll code up the Arduino using a software like MobiFlight to get the LED to turn on and off, or however we want it to do. So in this case, we're saying, I will turn the LED on at pin 2 whenever the gear is up. And you can also tell it to do other things too. Some quick facts about LEDs are that the LED is a diode, a light-emitting diode, so the polarity does matter. If you get it wrong, you'd have to switch it to make sure it's right. I always like to think of the memory aid that If you are positive, you will live longer. So the positive end of the LED is longer. Now, you can dim these if you use PWM. That's a function in Arduino that you can use on a PWM pin. Basically, it gives it like a value from 0 to 255, and that can control its brightness. Or you can use like a dedicated PWM light dimmer. That's also a way you can do it. A thing that's very important, any electrical engineer will tell you, is to never let out the magic smoke. The magic smoke circles around your electronics, and if it gets let out, the electronics don't work anymore. I actually believed that when I was very young, so I got a little confused about that. Just don't set anything on fire, and you'll be good. So this is all the calculations you do for an LED. You would have voltage of your LED, the forward voltage, which you find on the package. You have your forward current you find on the package. You put it into this voltage of the resistor equals the total voltage minus the LED voltage. And then you put this into this equation here, Ohm's law. It's not hard math, but it is boring. I like to instead use the lucky way sometimes. It's not very reliable. You can Google it, say, hey, I literally said, hey, what's that resistor thing that I should use for a 5-volt red LED? And it gave me this value, which is the same we got from the math. A more reliable way to do it, however, is to use an online calculator. This is the easiest, likely most reliable way to do it. You can just put in your power supply voltage, your LED voltage drop, your forward voltage, and then your LED current rating. So this is the forward current. And then your number of LEDs right here. And it'll even pop out this little schematic with the wiring and the resistor value where you put the ground. It's an amazing tool. So this ledcalculator.net can help you a lot with that. This is great, but that just lights up things. How do we get the sim to know what to do? So instead of an LED hooked up to a battery, we can say a switch is hooked up to a battery with an LED so it doesn't just burn up the battery. So it's doing the same thing. Whenever you flick the switch, it switches whatever you want in the sim. So this is also done through a software like MobiFlight, and this is where MobiFlight comes in really handy. It's a wonderful software. It's actually right here. It looks like this. And you can just hook up however many LEDs, push buttons, anything. This we ran in the workshops, but you have like an LCD here that you can control all sorts of different things, like your frequency. But that's the same software that we're using for this button right here. So now it senses the gear, the switch has changed, and it tells the gear what to do. Now, grounding is something very important, and I found this right meme very, very nerdy. We had to ground him. He's doing better currently, and he's conducting himself properly. It's one of those that just gets groans from myself, too. Right here, we can see this wiring setup we have here. We just have 4 buttons, and each are routed to a separate pin right here. Pin 2, pin 3, pin 4, and pin 5. And then we hook those up to MobiFlight, but we'll realize that there's not enough wires for this last switch right here. What do? Let's ignore the other switches, the other wires right here. We still have that problem. We don't have enough ground pins right here. So this is what you would do. This is called daisy chaining. You attach one cable to an LED and then attach that ground, or you attach the ground to one pin of the switch, attach that to the next pin of the switch, attach that switch pin to the next switch, attach that to the next, and you can go on quite a while with this. Another method to manage your ground situation is this is kind of called pigtail wiring. So you just route them all to the center and then tie them all together in one. So there are multiple ways of doing this. You just want to make sure you have really reliable connections. But how do we get those reliable connections? I recommend solder as almost always the answer. You can see a lot of my videos on YouTube. It's called Captain Bob Flight Simulation, but my heading indicator YouTube video has also crimping, where I just took 2 wires and put them into one terminal, and then you can kind of jump your way around wiring like that. That's one way to do it. There are also these WAGO connectors right here that are really fun. You can also snap them into your finger, and it hurts kind of a little bit. And then there's also these ground terminal blocks that are used more in likely more in industry, is where I usually see them. Also, there are some wiring tools you can use for getting these good connections right here. My favorite ones are these crimpers, the soldering iron, and then this wire stripper right here. This wire stripper is automatic, so it really gets a good, takes the insulation off really well. You also have this multimeter right here, and that is really nice to test voltages, test continuity. Basically, if you put the 2 probes together, they beep, which is that little Wi-Fi symbol. I thought it was like connected to the cloud, but it's actually, you make sure that the metal is connected to each other. Because if your wire comes disconnected anywhere, it won't beep. You also have your soldering iron, which is really, really, really a great skill to have. To anyone thinking of building their own components, I would highly recommend learning how to solder. It's an incredible skill. You also have your DuPont connector, and this one isn't needed as much if you know how to solder, but it can come in handy in a few cases. Now, because we're in Vegas, I had to use the "you're wired" quote. And then we have our wiring tips right here with our wire color. We have almost always black is for ground, and at least consumer, like low voltage electronics. I'll always have red as 5 volts, and then if I can, I'll use 12 volts as yellow. If I can't, I'll use 12 volts as red, and then just make sure to say, hey, this is 12 volts, be careful. I'll use usually white for everything else. And this is kind of the way it's done in aircraft. White is usually for just about everything. You can also use a completely arbitrary scale right here. This, I think, is the most intuitive arbitrary scale I could find. I kind of combined a few. So yellow is LEDs because they light up, white is switches and buttons, and then we have our other list of devices here. Blue is servos, and I just picked that because usually they're blue. This is kind of, I am a little guilty of this in that case. If there's 14 competing standards, someone will say, hey, we just need one that works, and then there are 15. But you can choose whatever wire standard you want for these devices, as long as you just keep it consistent and make sure to follow it. I really like using this it's Bintech Go 24 gauge high strand wire. I find it really easy to solder with and really durable. I would make sure it has a high strand count. Oftentimes, if you're buying cheap wire, they'll have a low strand count and it'll easily become disconnected. So I would make sure to use this high strand count wire if you can. And it doesn't necessarily have to be this brand. You can play around with different brands and see which ones you like the best. I would caution you not to use like super high current loads on this. So like things that draw a lot of electricity, because the thin wire can catch fire. Just like Google it, wire ampacity chart. That's like a $12 word right there. But you can just Google what's the limit of 24 gauge wire, and you can come up with a limit right there. So some of the wiring techniques that you'll use, the first ones that you'll likely ever see getting things to do, and these are the ones I use in a lot of my videos, not because they're the best, but because they're the most accessible, are these DuPont connectors. You just plug them in to one end, plug them, and get something to light up. Now, long term, these might not work great. They can kind of come out of their seats. They can get broken, bent, and they don't always have a super great connection. So the standard that I'm moving towards is JST-XH connectors, and these are used a lot in, MobiFlight uses these a lot, and these are the ones we used in the workshops, if anyone was attending those. In my opinion, they're way better than DuPont. They lock into place. You have to actually apply force to grab them out instead of accidentally like kicking them and having everything fly out. They use the same pad spacing as DuPont connectors, and they're really cool. It's so satisfying to click. They make things really easy to not mess up the wiring, and they're easily disconnectable. Now, D-sub miniature, or D-sub, is great for making panels modular. You can take the whole panel out at once. You can even get these breakout cards right here that you can like screw actual wire into super easily, or you can cut cables. These cables sometimes don't have all 15 pins like for VGA cables, but you can use as many as you can there. Another way you can make panels modular is using IDC connectors, and I really love using these IDC connectors. It stands for insulation displacement crimping, but basically they have these teeth and they go into the wires and chomp onto them. But you get this kind of computer style ribbon cable that goes along with it. I'm using this standard right here. I'll talk a little bit more about with these boards that just get connected to Arduinos, and that makes it super modular. I'll talk a little bit more about that later. Now, circuit boards. This is another great topic with wiring and flight simulation. There's kind of two sides of it. There's all aircraft are usually wired directly with a real wire, so making circuit boards is just makes it not as repairable. It makes it too hard to deal with. And then there's the other side that says most electronics are circuit boards. The circuit boards make wiring super easy, super clean. Less wire is great. So you kind of have to listen to both of these. If you want it to be like 100% authentic, you could go down normal wiring, but for most things I make, I use a circuit board now because it just keeps the wiring super simple, and I really think it's a lot more elegant. So I would say if you have like 10 to 20 wires, about that amount, you could go hand wiring and it would be fine, but once it gets more than like 15-ish, 15, 20, that's when I almost always go to circuit board, just because it makes everything a lot easier. You can have the traces built in, and it's not very hard to learn at all. Speaking of learning, there are three main circuit board softwares that I would consider accessible to hobbyists. Easy EDA, KiCad or KiCad, however you would like to pronounce it, and then Fusion 360 Electronics. I would definitely start off with Easy EDA. It seems to be the simplest, the easiest to use. It's all online, which keeps it really nice to have everything just saved in the cloud, don't have to worry about it. KiCad is open source. There's a lot of development around it, surrounding like device footprints, especially within the flight sim community. So this is a great tool as well. I would highly consider this. Fusion 360, I wouldn't necessarily recommend, however, because it is quite a learning curve and not for a good reason, in my opinion. It's kind of clunky. But it is nice if you're already designing something in Fusion 360 to just push it back and forth, keep the board outline as a 3D file. In my opinion, that's a really nice tool to have. But it does come at a price, and also money-wise price. Now let's talk about Captain Bob breakout board system, the Bob. This is the Bob. This is version 2.0. I haven't readied 2.1, which will be the first version to ship or to be released. But the breakout board system basically lets you have 2 Arduinos and then split it into a bunch of different devices here. So you can hook things up to 20-pin connectors, 30-pin connectors, or 40-pin connectors right here. And this 40-pin connector is split into 2 20-pin connectors. This will let you just plug in one single cable from the breakout board to the avionic or the instrument or whatever, and it'll allow really clean wiring that's modular. Again, modularity, for me at least, is very important because I like to try different setups, different styles of flying. So I could go for a retro 172 right here with all of the Bendix King avionics, or I could replace it all for some new Aspens. So this wiring, let's go a little into it because I just love this. I've been thinking about it for like weeks and weeks and weeks, just nonstop. But there's some rules to the game with my standard. Again, the 15th one. But the first pin is always on ground. That's kind of a common rule for electronics. And then the second pin is always 5 volts, and this just allows you to always have this power distribution, so you don't have to worry about powering your boards, although you still can power them externally through the circuit board. The pin 3 through whatever you want is always PWM. So the first top pins are PWM, so you always get this dimmable LEDs in your board. And then the middle pins, until you get to analog, are all just normal digital pins. The last pins are all analog, so you can hook up potentiometers. And this is really valuable because before you'd have to kind of line up your Arduino with your board, and they wouldn't always fit together. But this way, if you design your instruments within these constraints, any components will fit together, which is super nice to have this kind of flexible system. There are also some special rules. If you have a 20-pin or a 40-pin connector, SDA can be on pin 13, SCL can be on pin 14. That way you just make sure those line up. And then you also still maintain this PWM, digital, and analog ordering if you're going to mess with it. I also love to keep spreadsheets in general. It's been kind of a hobby with me. It's kind of not very interesting to mention in parties until I show them my hundreds of spreadsheets that are all color-coded and just kind of crazy. But I have this spreadsheet right here that just tells you which IDC connector pin. So that's, again, this pin 1, 2, 3, 4, 5, 6. That pin number. And it tells you what pin it goes to on the Arduino. The Arduino being this microcontroller right here. So that helps you keep track of everything, plan everything, and it also helps you make sure that you're not missing anything. It also tells you which pins are blank and then which ones you're using for what. I also keep component level spreadsheets. This is a little extra. You can just keep them on this spreadsheet right here in this tab. But I also have this spreadsheet available for you to copy. It'll be on the last slide. There'll be a picture of a QR code and a link. There are also other systems that you can use. So this is the MobiFlight prototype board. It has a bunch of JST-XH connectors, so you can just super easily plug in any electronics. It does have some limitations because you can only connect 2-pin devices to the 2-pin slots, but it is very cool to just be able to plug things in. And so you can use kind of this style of breakout board if you'd like to go down the circuit board route and make your own circuit boards like that. Or there's also another breakout board like kind of style I found. And this is the 737 DIY sim breakout board with these pin header, with these screw terminals right here. So you can find both of these. This one is on 737DIYsim.com/shop. It's just, you could Google DIY 737 breakout board. And then this one right here is on mobiflight.com/shop. So these are two other options if you'd like to just kind of break out everything. You can, of course, also use the DuPont connectors if you'd like, and you can crimp your own wires and make your own length of cables, and that's another way you can do it. If you group the DuPont connectors together, they tend to be a lot more sturdy than if you have them separate. So that is another tip that you can use. This is all I have for my wiring, but I would love to talk to you more if you have any questions or you'd like to talk about your setups. I'll be out in the hallway over there afterwards, but we have a little bit of time for question and answer. Does anyone have any questions? I don't know if we have a microphone too. Yes.
Tutorials to learn about some of this in more detail at the beginning. Can you recommend any sources, YouTube or websites or blogs or something?
Yeah, absolutely. So the question was, do you have any tutorial recommendations to learn all of this? Any like websites, blogs, resources? So my YouTube channel, I would recommend for all of the MobiFlight stuff. It's captainbobsim.com. And I forgot to mention, this is the I don't have a QR code, but captainbobsim.com/FSE2024 is a good page. It'll have the slideshow if you want to click on any of the links, or if you'd like to copy the spreadsheets. There's the MobiFlight YouTube channel. There's usually a getting started video that's usually pretty up to date. That just shows you in kind of a different way the LED and switch. So that's what we call the parking brake tutorial, just to get information sent out and received. There's also a lot of sim builders out there that are just fun to see, kind of follow along, kind of get some inspiration. So I kind of like to learn by osmosis, which is a big word for something with a bubble. But like following Helimech, like the DIY 737 YouTube channel, Mikey's Flight Deck, the Warthog Project, there are a ton of other ones too available. And then there's also the MobiFlight Discord, which can be found on MobiFlight. Are there any other questions? Or even things?
Yeah, I have a question.
Yes.
So, mounting circuit boards to flat surfaces, I have a need to mount them vertically.
Ooh, vertically.
Where I would use some sort of mounts or, the mounting screws. And I'm just wondering if there's anything I can glue it there.
Hmm.
What that might entail with grounding.
Right. Are you able to drill into it?
I'd rather not,
Okay.
but I could. Then I'd have to make a custom screw hole.
Right. Okay, so the question was, you have a circuit board, you want to mount it vertically. Like, what's a good way to go around that? I would go, honestly, command strips might be a good way to go. If you're not afraid of it, or if it's like your circuit board, you could like kind of snip the any protrusions that aren't needed, like the back of a pin header, flush just so you have a mounting surface, and then like command strip it. That might be a good way to go around it. You can also 3D print like cases to go around it, and then use perhaps epoxy, although if you don't want to damage the surface, that might not be a good option. So I would probably go with command strips in that case, and just make sure you have enough to support its weight. And also, if there are any cables coming from it that you don't want to yank it off, so you could put in a strain relief too. Yes. You're welcome. Any other questions? Yes.
On the last slide, or second to last slide, you showed the multiplied breakout board.
This one.
Yes. So can you connect more than one board together? I have a lot of instruments that I would connect.
Yes, so the MobiFlight breakout board right here is connected to an Arduino on the back. And then the question is, can you have more than one of these? The answer is yes. I would just rename them at the top just to make sure you have them all organized. But you can have, I believe, up to the 127. So you can have a lot of fun with MobiFlight, up to 127 funs right there. If there aren't any further questions, or do we have any last questions? All right, I think that is it. Thank you so much, and have an absolutely fantastic day.